Imagine that every time you try to stand up and walk, you can't. You just fall over. This is what happens in multiple sclerosis, and it's a disease that affects people of all ages. It's really unpredictable, and there isn't even direct evidence that it's genetically linked. Even though the life expectancy for this disease is relatively high, 25 to 30 years, people who live with this disease have to lead a miserable life. And this is the life that 2.3 million people have to lead. So now that I've told you how much multiple sclerosis sucks, what exactly is it? Well, multiple sclerosis is a degenerative brain and spinal cord disorder in which the myelin sheath, the protective sheath that covers nerve fibers in the central nervous system, is destroyed. Myelin is really useful in connecting the brain and the body, so without it, there's a loss of connection and you lose function in your legs. Current treatments include certain immune suppressants which mitigate the symptoms but don't treat the root cause. And that's why we look to stem cells. Stem cells show potential in actually regenerating myelin and actually treating the root cause instead of just getting rid of the symptoms. Stem cells are unspecialized cells that can differentiate into many of the body's cells. In order to control the differentiation of these stem cells, we use these things called growth factors. What a growth factor does is basically hold the stem cell's hand and help it to go towards the proper cell fate. Stem cells can go through 3 different lineages. These lineages give rise to different types of cells, and these lineages are the ectoderm, mesoderm, and endoderm lineages. So going back to the multiple sclerosis example, we know that the myelin sheath in the central nervous system is destroyed. And in the central nervous system, oligodendrocytes create myelin. So, in order to create an oligodendrocyte, the stem cell would need to be given proper growth factors in order to help it differentiate towards the ectoderm lineage and eventually become an oligodendrocyte. However, stem cell therapy isn't all sunshine and rainbows like it may seem. It has faced a lot of challenges that prevent its widespread implementation. There are 3 main things that are required for successful stem cell therapy. The stem cells need to be able to proliferate and differentiate. There needs to be scaffolds to hold the stem cells in place. And probably the most important, there needs to be presence of active biological cues or growth factors in order to help the stem cell become what you want it to. What's been happening in recent years is that clinical trials have been failing because of lack of sustained presence of active biological cues. And what this really means is that over time, the growth factors degrade. It's like food that hasn't been eaten. They just expire. And if this happens, your stem cell might differentiate into a type of cell that you don't want, or it might not differentiate at all. This is why my team and I created Regenerene, so that we can make stem cell therapy an effective treatment for people who have degenerative diseases like multiple sclerosis. And in order to do this, we turn to another technology, nanotechnology. By combining these 2 technologies, we can provide an active platform for inducing stem cell differentiation. Of all the nanomaterials that have been used in stem cell control, graphene is among the most prevalent. Graphene has some really amazing properties. Graphene is basically what you get when you separate off a layer of graphite. And graphite's a really ordinary material. It's just the stuff that goes in your pencils. But when you separate graphene from graphite, it starts to exhibit some really amazing properties. For example, graphene exhibits extreme strength, flexibility, has unique surface properties, and also versatile chemistry. And this allows it to form covalent and non-covalent bonds with biomolecules. Using these properties of graphene, we can hopefully induce stem cell differentiation and help it to become an effective treatment. And because of its superior abilities, graphene is probably the best material for helping in stem cell control. In order to help you visualize this a little better, here's an example. In this example, there was a growth factor, TGF-beta3, which is used for chondrogenesis, and it was put in a mixture with graphene. After incubation for an hour, the TGF-beta3 was adsorbed onto the surface of the graphene oxide, and as a result, the stem cell was able to receive a continuous supply of the growth factor, and it was able to differentiate properly. At Regenerene, we hope to exploit these amazing properties of graphene and stem cell therapy and combine them to make stem cell therapy a reality for people with degenerative diseases. Above all, we value radical transparency and thinking big, because if we're going to make a difference in the lives of millions of people, we need to think really big. And if we can do this, we can help to accelerate the research efforts that are currently being done and be one step closer to a disease-free world. Thank you.